Okay, now we're going to get into how to solve inequalities. It's very similar to solving equations. Your problems look very similar to solving equations with one major difference. If you take a look here, we see expressions on the left, an expression on the right, but instead of having that equal sign in the middle, we have an inequality sign. Just as a refresher, some of your inequality signs, when the arrow's pointed toward the left, you could remember left, less than. If it has the bar underneath, in either case, that means that includes whatever is on the right of it. So that just means less than or equal to. This symbol here means greater than, so you can remember when the arrow is pointed right, greater, R, greater. That's greater than. This one, again, with the bar, is going to be greater than or equal to. Another big difference with solving inequalities versus solving equations is that to express the answers, we use interval notation because we get a whole range of answers instead of just one answer like we did when we were solving equations. So we're going to go over that in this video. First of all, in the notes, it just talks about an open interval. That's when neither one of your endpoints are included. So whatever's on the left of the comma would be your left endpoint. Whatever's on the right of the comma would be your right endpoint. If you have parentheses, that means this is your set, but it does not include the endpoints. A closed interval will be shown with brackets. That means that both of your endpoints are included. Sometimes you can have one endpoint that's included and another one that is not. So in this case, your left endpoint is included, your right is not. In this case, your left, I think I said that backwards. Your left endpoint is not included, your right endpoint is included, whereas in this case, your left is included, your right is not. So a lot of times when you see numbers, both endpoints being numbers, that is the result of a solution of what's called a compound inequality. So that's where you have x in the middle and maybe some expressions on the right, and your final answer will have numbers on either side of x, and you can just kind of read that as x is in between those values. So a good example of that is if you go to the movies, you'll get a discount, you pay full price if you're in between, maybe 12 and 60 or something like that. And then if you're under 12, you pay a kid's price, so you get a discount. And if you're over 60, you get like senior citizens discount or something like that. So so this is just describing a situation where x is nestled in between two values. Other types of interval notation that you'll see is where you have a number endpoint on the left and then infinity on the right, or negative infinity on the left and a number endpoint on the right. When you see this symbol, this means the set of all real numbers. Okay, so let's get into it. We want to be able to write this here. -1 is less than or equal to x is less than or equal to 3. We want to be able to take that inequality and write it in interval notation. So let's start with a graph, and let's look at what it looks like on the graph. So 1 is going to be your smallest value, so that's going to go furthest on the left. 3 is going to be your largest value, so that's going to be on the right of your 1. They're both included, so I'm going to shade them in. And this is showing x is in between those two values. Now what we want to do is we want to translate this graph to interval notation. So your 1 is going to be included, your 3 is also going to be included, and we know that because of the bars. That means or equal to. And then also 1 is my left endpoint, 3 is my right endpoint. So you can pause the video and see if you can guess the correct answer. And if you guess this, then you are correct. Okay, so B is a little bit similar. The difference between A and B is, notice we don't have those bars underneath, but still I want to go ahead and draw a graph. So we have -4 is my smallest value, 0 is larger than -4, so we write those in order. This time we don't have the or equal to, so we're going to have open circles, and shade in between. Again, this is my left endpoint, this is my right endpoint. We're going to separate those with commas. Since they're not included, guess what? We're going to use parentheses. So there would be your answer. Okay, so moving on to when we don't have a compound inequality, what would that look like? So here we can see x is greater than 5. So let's draw a little graph of that. So here's 5, and this is saying x is greater than. Since we don't have the bar underneath, we're going to leave that open. We're going to shade to the right. So notice the solution is supposed to be anything beyond 5. So 5 would be my left endpoint. And then my right endpoint, notice it does not end, so my right endpoint would actually be infinity. And notice, since 5 is not included, it's in parentheses. Infinity is never included, so it's always going to be in parentheses. Okay, so let's take a look at the next one. X is less than or equal to 1. So here we have 1. Less than or equal to means we're going the other direction, and this time it is included, so I'm going to shade less than or equal to. So now my leftmost endpoint, if you look all the way to left, my arrow is shaded. So my leftmost endpoint is actually understood to be negative infinity. My right endpoint is the 1. The 1 is included this time, so this is where I'm going to have that half closed interval. And it's going to be closed on the 1 because that is the actual value that's included. Again, with negative infinity, we always get a parentheses on either positive or negative infinity. Now we're going to look at going backwards, that is being able to translate interval notation into inequalities. Notice this one both has numbers, so that means that is going to translate into a compound inequality. So we're going to have x in the middle. This is going to be my leftmost endpoint. That's going to be my rightmost endpoint. And then since this one is closed, since we do have a bracket there, I know to include that bar. Now notice for B, we only have one number in this case. The number is on the left. So remember up here when my number was on the left, that translated to a greater than sign. So I know I'm going to have a similar case here. When my number is on the left, I'm going to use a greater than sign. Okay, so why don't you pause the video and see if you can figure out C and D on your own. All right, so again, we have two numbers. So I know, again, it's going to be a compound inequality. X is going to be in the middle. This is my leftmost endpoint. That's my rightmost endpoint. So the 2 is going to go on the left. The 3 is going to go on the right. We want the bars underneath the symbols. Notice that for compound inequality signs, the arrows always point towards the left. So that we read this as 2 is less than or equal to x, which is less than or equal to 3. In order for it to translate correctly, the arrows always have to be pointed towards the left. Okay, so again here we have negative infinity on the left, and remember we had that earlier when we had a less than sign. So negative infinity on the left is going to translate to x is less than my right endpoint, which is -3.